Hello and welcome to Cafe Culture Northeast. Tonight we have a Cafe Scientifique session entitled Science Fictions, Exposing Fraud, Bias, Negligence, and Hype in Science. This session features Stuart Ritchie in conversation with Oliver Traldi. Now I'll introduce the speakers so that you have a bit of a sense of who they are. Oliver Traldi is a PhD student in the Department of Philosophy at the University of Notre Dame. He has a BA in Classics from Bard College and an MA in Philosophy from Tufts University. He's also a writer and he's a writing fellow at the Heterodox Academy. A former assistant editor at Ario, he's also published in many different publications, the Chronicle of Higher Education, Arc Digital, Tablet, and the National Review Online, among many others. His research interests include metaphysics, philosophy of science, and logic. Dr. Stuart Ritchie is a lecturer at the Institute of Psychiatry, Psychology, and Neuroscience at King's College London. His work focuses primarily on intelligence and cognitive ability. He's the winner of the 2015 Rising Star Award from the Association for Psychological Science and the author of two books, Intelligence, All That Matters, in 2016, and the book we're here to discuss tonight, Science Fiction, How Fraud, Bias, Negligence, and Hype Undermine the Search for Truth. In addition to this, he's written for many publications, The Times, Spectator, Washington Post, Wired, Literary Review, and Eon, and has appeared on radio programs on the BBC. Thank you very much for being here.
Thank you so much for the introduction.
Yeah, thank you, Mwenza. Hey, Stuart. Hey, everybody.
Hi.
So, Stuart, I figured I would start out. This book, Science Fictions of yours, is a book about the replication crisis, right?
Yeah.
So I figured I would start out by just asking, what is replication, and why is it the sort of thing that could be a crisis?
Yeah. Well, this is, I mean, the term replication crisis has been around in psychology, this stuff, academic psychology, for about 10 years now. And the idea was that around about 10 years ago, there was like a confluence of events, maybe 3 or 4 different kind of high profile events that all happened, which we can get into the details, which all kind of were all about other scientists finding serious flaws in the work of published, their published, their colleagues, their peers, and being unable to find the same results in their own labs when they went to find the same results. So that is, they were unable to replicate those results.
Right.
And it's one of the cornerstones. I mean, of course, there's a whole literature on philosophy of science about what counts as science and what are the important aspects of science and so on. But one of the important things that must be a part of this, and certainly part of the discussion, is replication, right? You should be able, in principle at least, to go into your lab and find the same result as someone has published in their paper, for that finding to be not just kind of a flash in the pan thing or something that's a statistical fluke or something even worse. I mean, obviously, I'm talking about fraud in the book as well, which does happen in some minority of cases. So it was it kind of shook psychology in about 2011, 2012, when there were these kind of serious replication failures, when results that people had relied on for decades, and certainly methods like scientific methods, statistical methods, and so on, that people had relied on for a long time, seemed to just fall apart when other independent people came along to try and replicate them, and that it kind of shook the foundations of psychology, and then that has kind of as I'm sure we'll discuss, spread into other areas that aren't just psychology research.
Right. So it sounds like when people hear replication crisis, it sounds very technical, but it sounds like what you're saying is, to an extent, if a result doesn't replicate, we stop thinking that it's true, right? We stop thinking that it's accurate. We start wanting to kind of remove it from the annals of the field in some sense. So it sounds like, to an extent, there's it's a crisis of accuracy or of truth in this field, right? We're overturning some sort of foundational results.
Yeah, I think that's right. I mean, one can go too far, because if someone comes along and tries to do a sloppy replication attempt, they don't do the experiment correctly, they don't pay attention to the instructions that you wrote in your original paper, and then they come along and say, well, your finding isn't true, I didn't replicate it. Obviously, that won't do. But these were, good faith attempts to try and replicate some scientific results, and they failed. And I think you're absolutely right that at least begins to cast doubt on the original finding. And the book that I've written kind of goes into the reasons why that might be, but it implies that it wasn't a real finding in the first place, that it was some kind of statistical aberration, a statistical fluke, or something else. Yeah.
So you mentioned sort of long-standing results and even sort of psychological or statistical methods that had been used to produce results that were overturned. So can you maybe tell us just some of the most, what were the biggest overturnings, I guess you would say? What were the biggest changes that came from the replication crisis? What are some big results that we no longer necessarily believe are true?
Well, one of the places that I start in one of the early chapters in the book is with the book, the Daniel Kahneman book, Thinking Fast and Slow, which, of course, like probably everyone on this call has read that book. I certainly read that book when it came out in 2011, I think.
Yeah, widely celebrated. Yeah,
massive book. Yeah, huge book, millions of copies. You can see it in. Well, remember when we used to go to airports? You could see it in airport bookshops and stuff. I can vaguely remember airports. And it had a chapter where Daniel Kahneman described priming research. That is, in social psychology, there were all these experiments where some kind of idea in the world, so like someone had said an idiom to you, like, or just primed the idea of some kind of phrase or idiom in your mind, and that had a huge effect on your behavior. So one of the examples he gives is this money priming thing where they had participants come into a room and sit down and do some kind of distraction task on a bit of paper. And in front of them, there was a computer screen with a screensaver on it. And apparently, according to this, and this was published in the mainstream psychology journal, if you had a screensaver with like floating dollar bills, like money on it, that massively affected people's behavior later. And they were much more selfish in dealing with other people. And there's a whole literature on this where like these
money priming.
Yeah, money priming, but also priming in general, where these little tiny changes to the world had these huge effects on people's behavior. And Daniel Kahneman famously said, or perhaps infamously said in the book, this isn't just true in the experiments, it's true of you, and you have no choice but to believe that this is true. So now think about how many millions of people have read that and have thought, well, okay, it's true. And of course, after that book was written, these experiments started to fall apart. Other independent people started to come along and try to run those experiments in their own labs. That did not succeed in many cases. The meta-analyses that came out summarizing the literature afterwards were not kind to a lot of the priming. These kind of some people call it social priming. Some people don't like that, but these kind of ideas did not. So that was one thing in psychology, and you might think that's not, a massively important thing, but it is something that millions of people have read about and been told they must believe by a Nobel Prize winning, massively authoritative source, who, by the way, has come out and apologized afterwards and said, look, I didn't really, I shouldn't have said you have no choice but to believe these results. I made a mistake. I didn't assess the quality of the experiments in enough detail. So, good on Daniel Kahneman.
Yeah, that sounds like the right reaction to have. One thing that you mentioned, I'm now skipping kind of to the end of your book, so hopefully we started with the start. Well, then we'll go to the end, and maybe we'll get the stuff in the middle at the end somehow. But what you were just saying about Kahneman and all of the copies that his book sold and things like that, maybe not true in Kahneman's case, but it reminded me of at the end of the book, you talk about the incentives of science and how, in a way, bad research can be rewarded by bad incentives or by perverse incentives in the scientific community. So can you tell us a little bit more about that as kind of maybe the background on how science works? So what are some of the bad incentives that can lead people to producing the wrong kind of research or not being careful enough, or even, as we'll get to, even promulgating fraudulent results and things?
Yeah. Well, one of the arguments the book makes is that the scientific system, or certainly the academic system, the book isn't an attack on science per se. It's an attack on how science is done, right? And so in the
Right.
academic system now, the incentives are not necessarily what you might think if you were naively coming into science. You would think, well, the incentives would be to discover true things about the world and or at least accurate, reliable,
Right.
publish accurate, reliable experiments. Make new things that work, help people. You could think of all these kind of incentives. You'd think they would be the incentives, but in fact, in practice, the incentives are things like make your CV longer by publishing papers, publishing more and more and more papers, publishing those papers in journals that have a high impact factor. That is, journals that are prestigious, where the papers tend to go on and get cited more often. Getting attention to your research. Getting more money for your research.
Right.
And so, like, getting more money for your research and getting attention for your research, they kind of sound like, and also, publishing prestigious papers, they kind of sound like the things you want, right? They kind of sound like the things you want scientists to be doing, but they're actually just means to an end. And the end is publishing reliable results that will inform our knowledge of the world. But the problem is we're focused on the means, right? We're focused on just getting those articles out no matter what. And this produces a system, I argue, that where scientists are churning out papers that are generally quite low quality. They're rushed. They're in this huge rush constantly to publish more and more and more papers. These lengthening CVs. You can compare now to 10 years ago, or maybe even longer. And the average person starting a postdoc or starting a kind of early faculty position has a much longer CV now than people 10 years ago. And I don't think it's because people have become massively more productive. It's because the quality of the work has gone down, right? And so they've been able to produce more stuff. And so those kind of perverse incentives lead to all the weird things you see in academia, like salami slicing, where people publish, they call it the least publishable unit, where they publish one study that could have been in one paper, but they publish it across 5 different papers to kind of water it down, make it go further. And you see all these predatory journals, which I think wouldn't exist without this kind of weird incentive to try and push us to publish more work. So there's all these kind of fake journals that are kind of constantly emailing academics to say, please pay to publish your result in our journal, and we'll just get it out. And you don't need to worry about peer review or anything like that. And they also, I think, push scientists towards the sorts of stuff that's in the subtitle of the book: fraud, bias, negligence, hype, which undermine the quality of the research we're putting out.
Of course, yeah. Even in philosophy, we have this. The number of papers that's required to get a job or then to get tenure in philosophy has gone way up in the past decade or so. It's not uncommon if you're showing a paper to somebody for comments. It's not uncommon to hear back as a response, I actually think you could get 2 or 3 papers out of this, which is in a way it's the dream, but it's in a way, it's kind of like, it's really only one paper. I'm not, I'm not trying to slice the salami here. I'm just trying to do some good philosophy. But yeah, let's go on to that subtitle. So, remind us again what the four types of errors you're talking about, or the 4 types of ways that things can end up not replicated, and maybe give us some of the juiciest examples, some of the best stories, because the book also had a lot of these really, the things that people got away with, or the accidents that people made without realizing it, were pretty incredible sometimes.
Yeah. Well, the first one, which is the kind of the most scary example, is fraud, right? Where scientists are making results up, they're fabricating data, or they're altering real data in ways that make it no longer real. So fabrication or falsification of data. And there are some examples. The example I open with in the book is Stuart Ritchie, who was a social psychologist, who literally sat down with an Excel spreadsheet, like an empty Excel spreadsheet, and typed the numbers in that he wanted for his experiments to be. And he would give those data sets to colleagues in his department. They would say, I'm really interested in the effect of, I don't know what it would be, the effect of this, being in this particular environment on people's beliefs about, I don't know, sexism or something. And he would say, I actually have been working on something along those lines. I'll send you the data set. And then he would go and make the data set and send them it. And so he, not only did he, publish papers, just with his own name, he kind of ruined the careers of lots of other people, or certainly, or risked the careers of lots of other people, including his PhD students, by giving them these false data sets. And he wrote this fascinating kind of, I guess it's an autobiography, a memoir, or whatever you want to call it, which was translated into English by my friend Nick Brown, which is well worth reading. It's free online. We don't want to give a fraudster any money for it, I guess. It's free online, and you can get some insight, I think, into what he was, he was thinking. Well, other people have published results that look kind of similar to this. So even if this experiment is made up, it's probably kind of close to the truth. So I'll just give it a little push in the right direction, And also he explicitly mentioned the sorts of things that I've been talking about, where he said, other people seem to be, really on top of publishing loads and loads of papers. I'm having a bit of trouble in my real, in the real experiments I'm doing just aren't turning out the way I want. So, maybe I'll just end up making a few things up. So there's lots of examples of that, including some more kind of deadly ones in the world of medicine, where patients are dying in botched experiments, and then the scientists are fraudulently making up the results and reporting them to the scientific community as if these were wonderful, miraculous experiments. But that's a small proportion, right? I think if you ask scientists, have you ever committed fraud? 2% of them will say, yes to that question. So 2%, which is, a terrifying number, really, when you think about it, given how many scientists there are and how important it is, and so on. But if you ask them, do you know any other scientists who have committed fraud? I think the number there is 14% will say yes. I think that's probably true. But either way, it's a minority. And what I then go on to say is that there are subtler forms of unconscious bias that also pervade scientific research that essentially make the research unreliable in the same way as fraud does, although they're not so extreme, but are more insidious because you can kind of convince yourself that what you're doing is right. So you can kind of convince yourself that, well, that those numbers don't quite make sense. That participant wasn't paying attention. I'll just drop them out of the experiment, and we'll just try the analysis. We'll just try a few more participants because we need, more data is good. And these are all, things that scientists regularly do. And the problem is that they increase the likelihood of getting a false positive result. With the way we standardly do statistics and the frequentist paradigm of statistics that most scientists use, the more times you run an analysis, the more different ways you try it, the more different times you roll the dice, basically, the more likely you are to find a false positive result. And so there's all these ways I describe in the book of how scientists can produce false positive results from their experiments. So that's kind of bias of the statistical kind. I also talk about bias of the political kind, bias of the kind where you just want your result to come out in a positive way. Right. It would help. It would be really nice if it did that. You'd feel like you're making a difference. And so, you're more likely to publish the positive one and not really bother writing up the negative result that you found or the result that was null and the experiment that didn't really go anywhere. I think you sort of see this in COVID-19, where people are just this massive flood of papers where people are like, I can apply whatever I'm doing to COVID-19. I saw a paper about, this is a few months ago, I saw a paper about finger digit ratio and COVID-19. It was like, some people were like, oh, well, we researched digit ratio. Let's see if that correlates with COVID-19.
Right.
So, people just
the old hammer and nail problem.
Right, precisely. Yeah. And then, there's a chapter in the book on negligence, where scientists are just like, there's some algorithms that have kind of trawled through loads of data and found all these errors, some of which completely flip the results of experiments. In some psychology papers, about 5% of them had an error that would be completely flip the results. And that
like
might
a sign error, like something is listed as negative where it should be positive or something like that.
Right, exactly. Yeah. And it was like an inconsistent number where, there are these numbers. I think the analogy I give in the paper, it's like a triangle where it's like the hypotenuse in the triangle where you have the other two sides, you can always work out what the hypotenuse is. If you've got, two of these numbers, you can always work out what the p-value is, or vice versa. There are lots of cases where those are inconsistent. So something's gone wrong. And in most cases, it's probably just because someone did a copy and paste error or something like that. There are also cases where cell biologists are like letting their cell lines get mixed up and contaminated by other cell lines. So they think they're working on human cells, but they're actually working on monkey cells, or vice versa, or whatever. Happens all the time and has been happening since the 1950s, since cell lines were first developed, and people haven't really done anything about it. And there's all these editorials appearing in high-profile journals saying, "Can we please do something about this?" And nothing really ever gets done. And then the last one is kind of takes us back to the Daniel Kahneman stuff, which is hype, which is where scientists are writing about stuff in the public domain, which isn't really based on the evidence, or it's not that the books I take aim at are things like Carol Dweck's mindset book, and that book Why We Sleep by Matthew Walker, which is another massive success. It's not that they're wrong. It's not that the data are fraudulent or anything like that. No way. It's that there's something there. There's something interesting there. But the scientists, again, because of the incentives of talking to the public, are hyping it up way beyond what the data can support. And I also talk about press releases, which is how a lot of people hear about science results in the first place. And I think they don't realize that scientists themselves are writing those press releases and are kind of bigging up their findings, again, because the incentive is to get more attention to your research, because if you do that, you're more likely to get more funding in future and so on. So I think the perverse incentives kind of lead people towards, in the wrong direction in all these different ways. I think they all lead to some large proportion of research being extremely unreliable. And it gets me into the case where, a few years ago, 10 years ago, whatever, I would see a new scientific finding and I would think, oh, cool. And now I see a new scientific finding and I think, I wonder if it's been subject to any of these problems. And I think that's really sad.
I think that's sad too. And that's something that I really wanted to ask too. So in philosophy, there's kind of two ways that we think about, what's called epistemology, the study of knowledge, study of justification, things like that. One is, there's kind of an institutional approach, how do institutions produce knowledge and things like that? How do we make sure that kind of at a social level, we have more knowledge? But the other is just the individual level. So, an individual person who's trying to gain evidence about the world, trying to reason about the world, observing and thinking and things like that. So I was kind of wondering, as an individual reasoner, what should we be thinking now if we see some new scientific finding? How skeptical should we be? I know that I've seen I believe there are now prediction markets, right, for scientific results. So just to explain to everybody listening, a prediction market is basically you place a bet, or you buy a share, really, in one event happening or not happening. So in essence, in a prediction market for scientific findings, you're betting on whether they'll replicate. You're betting on whether the next person who tries to get the same findings will find it again. So how skeptical should people be of scientific findings, and what are are there clues that we can use when we see a paper come out, okay, this is science, we can accept it, versus I think this is, hype, or somebody's making something up or something like that?
I think there's different levels of clues that you can find. So if you're willing to dig into the paper itself, there are lots of kind of statistical things which you can look for. Oftentimes that's not the most reliable way of going about it, because first of all, it's easy, even if you know statistics quite well, it's easy to kind of not know the full context that they're being used in, and kind of not realize that actually something is fine when you think it's bad, or vice versa. If you're not an expert in that particular area, it can be quite tricky. But there are some things to kind of look out for, and I talk about p-values being which is this way that scientists use of trying to split apart noise from signal. They're kind of slightly abused, and there's a kind of long explanation in the book of how all that works. And it's probably fairly pointless to go into it now, but because it's such a convoluted thing.
But I think, a simple way is, I think I've seen a chart where, so a p-value, if the p-value is under a certain amount, then we think the result, in the most basic sense, we start to trust the result. And if it's over that amount, then we're not ready to trust it yet. And I think that, or over a certain level, I think I saw a chart once where right when you get right under that level, there's this immense rise in the
Yes.
number of papers that somehow get a p-value
Yeah.
right exactly where it's supposed to be, which just, even without knowing the content of the papers, seems like some of them must be doing something wrong.
Yeah. So it's this kind of sacred threshold, the p equals 0.05 threshold, where to get a statistically significant result, your p-value has to be lower than this threshold. And yeah, right enough, if you look across papers, there's this mysterious bump where there's way too many values than we would expect, just if things were working completely randomly. There's way too many values that are 0.049, 0.048, 0.047, like just under the threshold, which we use to, in many cases, we use to decide whether to publish a result, right? Because we're more interested in publishing positive results than null ones, so it's that can be somewhat worrying. And that implies, by the way, that what scientists are doing is so-called p-hacking, which is that they're running, as I described a few moments ago, they're kind of running the experiment and running the statistical analysis over and over and over again until they get the analysis that they want. Maybe dropping one participant out. One set of petri dishes doesn't get used in the experiment. Some of the data points get dropped, and they control for something that they didn't plan to do. Basically, they run an analysis in a flexible way when really statistical analyses need to be run in a very principled way. I think if you stopped someone in the street and said, do you think scientists, before they do an experiment, write down exactly what they're going to do and write down exactly how they're going to analyze the experiment? That's A. Or B, do you think they kind of have an idea in their head of what they're going to do, and then they collect data, and then they kind of just mess around with that data until it sort of shows what they kind of were expecting, and then publish it? I think most people would say that they think it's A, but in many cases it's B, and in many cases scientists are entirely unprincipled about the analysis they do. They'll just try it again with in some other combination, in some other way, and it'll end up being certainly much more likely to be a false positive.
Right. But even this, this, you call it unprincipled, but even this is not something in your book that you count as fraud, right? Because most of the time we figure that there's so many reasons that somebody could do this, and probably often a scientist in their own head, they're thinking, well, I know this result is true, so I must have just, I must have done something wrong the first time, so I'll do it again, and this time it'll go right.
Yeah,
and it seems like that.
I think it's a blur, right? There's a blur between that and fraud. There's like it's not easy to like say, well, if you do this, it's fraudulent, because I think some people do it without knowing, and some people do it with varying degrees of knowledge about how bad it is. And I think if you really know how bad it is and yet you still do it, that's getting into the realm of fraud.
Right. That makes sense.
So yeah, there were. I mean, so looking for suspiciously just under the level p-values is one thing. But I think outside of the papers themselves, I think you can, and probably this is the sort of information that the people in the prediction markets that you mentioned are using. I think findings that are particularly counterintuitive or surprising, I think are less likely to be replicable. I mean, people are very good in social psychology. It turns out, there was a paper just a couple of weeks ago. People are very good at now realizing the kind of social psychology experiments that are less reliable. Of course, maybe those people know about the replication crisis, and so it's hard to run the tape of the world again and not have a replication crisis and so on. But they're quite good at realizing, I think, that papers which say things like, seeing, and this is a genuine paper that was published in the journal Psychological Science, seeing an American flag just popping up for a few seconds in the corner of the screen while you're doing some other task makes you vastly more likely to vote Republican in the next presidential election. Like, things which just are absurd, and yet they were published in the journals. And also, I think people should be rightly skeptical of analyses which seem to very neatly back up a particular political or other kind of agenda.
Right.
I think if you see scientists writing about results in writing about their results in a way that makes it seem like they would have been really upset if they'd found something else, or they feel like they've done the right thing by finding this result, then things might not be so reliable. I also think an underrated tool that people can use is just to look up the internet discussion about a paper, right? So I think we've particularly noticed this with COVID-19, where every new paper that comes out, people are writing threads on it, on Twitter and commenting on various other websites and so on. And quite a few, dodgy COVID-19 papers have been caught out because of this. People just looking through it and going, that doesn't make sense. This doesn't make sense. And putting it online and saying, hey, what do you guys think of this? There's much more of that now than there was, just a few years ago. There's much more of this discussion, post-publication peer review, people call it. I mean, obviously, peer review normally happens before the publication, but so obviously you have to realize that when you do that, you get uninformed criticism and uninformed discussion too, and people with an agenda and all that. But I think you can find, useful discussion just by seeing what people are saying about a paper. The best media reports about a paper too the journalist will have gone out and asked an independent scientist what they think. And there's organizations that do this. So for instance, the Science Media Centre in the UK, and I think there are equivalents in other countries, they go out and ask a whole bunch of scientists what they think when some new paper comes out that might be, important in, a health sense, or might be important politically, economically, whatever it is. They'll go out and ask a bunch of scientists and say, do you think this is reliable? And they'll get a little statement from each of the scientists. So that's a kind of independent analysis that you can kind of you can certainly use when you're trying to evaluate a paper. So whereas it does, you do probably need the expertise to write a proper critique of a paper, like in that subject area. I think you can get some good indicators just by seeing what other people are saying. And I talk in the book about how the whole point of science is it's this social process where we're all arguing with each other all the time. And I think if you deliberately go and seek out that argument, which is usually happening somewhere online, then you can get
right. That makes a lot of sense. Well, I think maybe it's a good time to move to the Q&A, and I have a couple more questions. So if maybe I'll ask them at some point during the Q&A, or maybe we'll have enough questions in the Q&A.
Sure.
That I won't. So first question is, well, this is kind of two questions in one. So the first part of the question is, so we've got within psychology, we've got social psychology, and then within science as a whole, we've got psychology. So a lot of the results you talk about, and a lot of the most publicized results that have come under scrutiny have been from social psychology, this subfield of psychology, and a lot of the ones that haven't have been from the rest of psychology. So what about the rest of science? Is anybody safe? What has happened in other fields as a result of the replication crisis in psychology? Have they had their own replication crises? And what about within psychology? So you work, we mentioned kind of the areas you work on. You have a book on intelligence that came out before this one. So what makes some fields in psychology different? Is it just kind of people being vigilant? Is there some difference in the subject matter? What are your thoughts on that?
Good questions. I mean, the first one about other fields that have had this problem, or how's the replication crisis been in other fields? I mean, there are papers. If you just look up replication crisis or any kind of news articles, there are all this succession of news articles across the last 10 years, which is like, economics is now having a replication crisis. AI is now having a replication crisis. Ecology and evolutionary sciences are now having a replication crisis. And it kind of goes through, because people kind of realize over time, they have this kind of self-realization. And I don't think any fields, because the replication crisis kind of started in psychology, and this whole discourse kind of started in psychology, I don't think any other fields really have, to the same extent, done the self-analysis where they've gone out, like psychologists have done, and gone out into the world and collected loads of data on the same experiment run in loads of different places, so you can see whether it replicates and the reliability of the findings and so on. I don't think other fields have really done that to the same extent. So it's kind of a bit of a mystery whether they're in the same state as psychology research, which is a bit worrying. I think there are certainly a lot of the same kind of glimmers of the problem.
Right.
Scariest, of course, is the replication crisis that affects medical research, where it's actually treatments that doctors are using, where another study comes along a few years later and finds the exact opposite effect, or flips what was previously the medical consensus. And that medical consensus was based on low quality research, maybe p-hacked, maybe biased in some way, or just maybe just, you know, not really ready for prime time. It should have been preliminary research, and it turned out to be, it was kind of made out to be something more than it was. Yeah, I think these kind of same ideas are kind of spreading out into other areas too. That's a worry. And also, I should say, like, some of the solutions that, you know, psychologists have come up with about being more rigorous about your analysis, planning it beforehand, sharing your data online so that you know, I've got nothing to hide, have a look at my data, you know, and various other ways about reforming the academic system have also been taken on board by other subjects as well. So it's kind of a reciprocal thing, I guess. So that's one thing. The next thing you asked was about different areas of psychology, and whether different areas of psychology are more replicable or not. Certainly, I think the problem I discussed earlier about social psychology findings being really counterintuitive and flashy and exciting and like easy to understand. If you one of Diederik Stapel, the fraudsters, one of his findings was, if you're in a messier room, you'll be more racist, right? People have messier desks, or more like, that's the sort of thing where you can imagine a BuzzFeed article. I'm not sure if BuzzFeed was a thing when that came out, but you know, there were those kind of media articles that, you know, that came out, and lots of clicks for that kind of thing. And so I kind of think that sort of research, and again, the prediction markets would bear this out. You know, people are quite good at spotting that is a wee bit less reliable. Other areas of psychology, I think basically the more boring areas of psychology are more reliable, right? And I don't mean necessarily boring in a pejorative sense there. I just mean the ones that are less likely to get a media headline. I think you know, evidence from cognitive psychology of people like you know, pressing buttons on a computer when a light goes on, and theories of processing speed and its relation to other cognitive abilities and stuff are pretty solid, but it's just not the sort of thing that's going to get people really excited and get you publications in the top journals and so on. So it's almost the areas that are kind of anti this kind of perverse incentive thing. My own field, intelligence, there was a paper just last week or the week before, where people looked at the sort of quality of research in intelligence in the same way that they looked at the quality of research in, you know, social psychology and so on. And they tend to find that it looks a little bit better than other areas. So it tends to be that the statistical power, which is to some degree a function of the sample size, it kind of makes the findings, it's another part of the recipe that makes findings more reliable, was not as bad in intelligence research. It's not great, but it's not as bad. And again, I think some of the findings in intelligence research are of the kind of slightly more boring kind, like people who score better on tests, it predicts how well they do in various things in life, like how well they do in school, how well they do in their job, and all that. It's not that, you know, groundbreakingly, massively exciting. I argue it's important to know about, important to study, and important to know the limits of that and know how much that matters and so on. But it's not the sort of thing that Daniel Kahneman is going to write a chapter about and say, this is, you know, going to, you know, this is the sort of thing you must. It's
going to blow your mind. Yeah,
exactly. It's not a Freakonomics style result. It's not a, you know, a BuzzFeed type result. I don't mean to denigrate BuzzFeed. You know what I mean?
Of course, yeah. Well, the next question is kind of building on that. So somebody asks, are there scientific fields that are more prone to hype and negligence, or more or less prone, you know, than your average scientific field? And what do you think goes into that?
Well, I think this fits. Again, you know, my own subject, psychology. I think the reason that psychology seems to be, and probably one of the reasons that the replication crisis kind of started with us, was that, you know, people care about psychology much more, right? People care about the results in psychology much more than they care about the results in physical chemistry or something, because it directly impinges on their lives, right? So they can have an ideological opposition to findings in psychology. They can share findings about psychology with their friends. It can change the way they think about how people interact with each other and how people are. So I think that means that you know, the sort of media attention that you can get from being a psychologist is probably a lot better, and it also means that the results are somewhat flimsier in that you can be the sort of person who's going for who's going for publications and media interest and all that, rather than someone who's just really obsessively interested about how some particular molecule works or some
Right.
particular, part of I don't know, some boring part of some other field, right? Not boring to them, and not boring in the grand scheme of things, but I'm
Right.
using boring in this kind of non-media sense.
Publicly boring, boring
absolutely.
to people who might write newspapers and magazines. And like
And
that.
you can write whole books about psychology findings where you say this will change your life. And also I think one other thing to say about psychology is that it's really difficult. Doing psychology properly is extremely difficult. Human beings are extremely hard to understand. They're very complex systems with all sorts of stuff going on. Different personalities, different previous experiences, different influences on them right now, different cultures, different background, everything that makes psychology one of the hardest sciences. Obviously people think it's one of the softer sciences, but not in theory. In theory, psychology is one of the hardest things to understand. The human brain is one of the more complicated things to understand. So I think a lot of our early attempts to do that are often unreliable because we're just not really that good at measuring a lot of things in psychology. They're not tangible things like in other fields maybe where you can actually, physically hold something that you're measuring. How do you physically hold like a belief or a desire or an ability or all that? So,
or some construct like G or something like that.
Right. A statistical construct like general intelligence or personality traits. So, it's interesting to think about, what are the more or less reliable things. Another interesting thought I had, and this comes from a paper by Robert Plomin, who published this in 2016 or so. He wrote this paper about why are findings from his subject, which is behavior genetics, why are they more, he was kind of saying, I don't think these are subject to the same problems as social psychology and replication and so on. Why is that? And one of the kind of examples he gave is that they are often under attack a lot because they're controversial, right? They're politically controversial. There being genetic variants in things like intelligence or personality or psychiatric illnesses or whatever is a controversial thing. It's always been very controversial. And so it's almost like they're constantly under attack and you're getting extra peer review all the time because you're having to justify yourself. So that's one of the ideas that Plomin gives in his paper. And obviously some people would say, well, twin studies are all a load of nonsense and so on, but they do find very, very reliable results about the heritability of psychological constructs, for instance, and so on. And it's not that they just fall to pieces whenever someone tries to replicate them. You do get very consistent results. And so part of that might be that they're really plugged into the mains of scientific debate. That might also be the case for kind of intelligence IQ stuff as well.
That makes sense. I've got a bunch of questions now. Hopefully this isn't putting you in an awkward position, but a bunch of questions where people ask you to comment on some specific area or line of research.
Sure. Okay.
So the first one is one you already mentioned about growth mindset research and Carol Dweck's work. So yeah, go ahead.
Well, yeah, I mean, I mentioned her in the book as an example, and she's in the hype chapter. And I think it's an interesting story what's happened with the mindset stuff. If you rewind a few years and go back to 2005-06, I think, when this was first being talked about, or certainly when the popular book came out, I think there had been research on it before that, but when the popular book called Mindset came out, forgive me if I got the date wrong, but I think it's about 2005-06. It was essentially a self-help book, right? It was Stanford University professor Carol Dweck is telling you how to change your life by using mindset. And the idea is that kids, if you teach kids that they can change and grow and that their mental abilities are, plastic, basically, that they can change them, then they'll do much better than if they get the impression that actually there's nothing you can do. You're kind of stuck the way you are. You can't change and so on. That would be a fixed mindset as opposed to a growth mindset. So, I mean, the genius idea of mindset was kind of calling it mindset, right? Rather than just, if you work hard, then you can change, and which I think is an idea that's kind of been around for a long time. And if you read, and I have some quotes from the book in my book, if you read that original mindset book, it's things like, if you understand mindset, then you will understand yourself in new ways. You'll understand your kids. You'll understand your partner. This really could, and you really come away with the impression that this is a life-changing thing. In 2018, a meta-analysis came along that analyzed all the data on mindset. So two kinds of studies. One kind where they correlate people's levels of mindset, like they give them a questionnaire, like how much do you think you can change your mental abilities and whatever. They correlated that with their academic success, so their school grades, whatever else. And then the other kind of research is where they tried to go in and intervene and try and actually change people's mindsets and then see if that leads to improvements to their grades. And in both cases, they found that there was a correlation between growth mindset and academic ability. And B, if you change people's mindset, it has an effect. But in both cases, it's very, very, very small, right? It's a very minor impact that this growth mindset stuff has in an educational context. And then, and comparing that to the original claims is kind of mind-boggling, because you think, well, how could something which has such a small effect have these massive, dramatic, life-changing things? And the reason is because it doesn't. It was written in a hyped-up way. It went beyond the data that were available, and then there's been this kind of unspoken process of just rowing it back. And Dweck herself is a co-author on papers that now show that it's kind of a thing that might be important. If you rolled it out across every student in the country and it had a minor effect, that would be really good, because it would boost everyone's education by a little tiny bit, and that'd be good. But it's not a life-changing thing on an individual level, and it's irresponsible, I think, for scientists to say that things are massively important and life-changing when in fact they're not really, especially when they have a kind of a conflict of interest in doing so, right? And published a book on it and so on. So that's my view on the mindset stuff, and I think it's been borne out by the research over the past few years, which is really kind of saying there's something here, but it's nowhere near as big as Dweck originally claimed.
Now, is that, I'm going to kind of insert my own question here, kind of relating to something we talked about before. You said your idea was borne out. So was that something that you kind of expected looking at this research? You looked at the amount of hype, you looked at sort of the convenience of the belief, it sort of fits with this belief about we're very malleable, we can make ourselves into whatever we want. We're not tied down to, to the set of abilities we have. It's a very hopeful and optimistic thing. So were those sorts of qualities that you used even before this meta-analysis came out to sort of look at it and say, I've got some doubts, I don't think this is necessarily going to turn out to live up to it?
Yeah, I think so. I mean, I before that meta-analysis came out, I was kind of vaguely familiar with some of the big papers in the mindset literature, and I think they were quite flimsy. Like I think some of the statistical analyses, if you look into them, really, were very borderline. It was those p-values of just under the borderline and all that stuff that we've talked about. I think it fits quite nicely into what we've discussed, actually. And then, as you say, there's also the other thing which I previously mentioned, which is like the psychologists really want to believe this. The people doing the experiments really want to believe that mindset is this vastly important thing that will change your life, and so they found that in the papers. And some of the claims, I mean, one thing I didn't mention was there's a set of papers on mindset, again, I have to say, with p-values that don't look particularly robust, saying that using mindset, we could solve the Middle East peace process. You use mindset on Jewish people and Muslims in Israel and Palestine, and it would like sort out their problems because they realize that we can all change. Just these massive claims that are being made on the basis of just very, not impressive statistics. So I was always a bit suspicious. And then that meta-analysis came out, and I wasn't surprised that what it said was, sure, it's better to believe that you can change than have the belief that you're just, never ever going to be able to better yourself in any way. But it's not that much better. And it's not the sort of thing where you can go along and just say to kids with a worksheet, which is usually what it is, or like a brief intervention for a few minutes, and say, by the way, science tells you that you can improve your brain, you change your brain. And then suddenly they all go, aha, and their IQ goes up by 15 points. I mean, that's just not not
believable. Okay, so next question I have, it says, and then I kind of add a little bit to it. It says, Gina Rippon's work, or Rippon, I don't know how to pronounce her name, but you probably know her name. Her work on the gendered brain seems to be, it's an example of research that's driven by political concerns, but it's also heavily empirically based, and she would argue that it's empirically stronger than rival accounts. So the questioner asked, what does Stuart think of this kind of politically charged research? And I kind of have my additional question is, what should we do about a topic where there's sort of political pressures on both sides, where there's sort of no escaping the fact that either result you come up with will be convenient to somebody politically?
Yeah, it's a really difficult question. Gina and I and Kevin Mitchell and Daphne Joel had a debate on Intelligence Squared near the start of the lockdown. There's often a few months between the live event and the recording going out. I'm not actually sure if the recording is out, but we did a debate where we talked about this exact issue about the sex differences in the brain and so on. So yeah, I think it's really difficult. I think the only thing we can do is adopt the open practices that I talked about. So if instead of publishing a paper where the analysis may have changed along the way, if we all set our analysis up beforehand and say, I will agree that this hypothesis is true if the data show exactly this, right? I think that can actually be extremely helpful in dealing with these very charged questions, because it removes any like accusations of bias on the part of one particular researcher or another, but it just transparently it gives you an example of scientists who are trying to get to the truth rather than just publish a paper, right? So I think using these kind of open practices, and actually the whole idea of doing I always forget the term that's used, but it's like an antagonistic collaboration or something it's called, where you work alongside people who are opposed to your view, so people who think that there are sex differences in the brain and then they're really important would work alongside people who think that there aren't that many sex differences in the brain or that they're not that important. And then they would come together and actually decide on something beforehand. This has happened I think this is happening right now in parapsychology, the idea of like psychic powers and so on, where skeptics and believers try to collaborate with each other and so on. I do see some cause for optimism in those kinds of things where people can get together. People can get together and sort of agree beforehand on what things should be like. But even if you can't do that, I think just being open with your data,
right,
will help us get to the answer, because other people can come along and say, well, I don't think that should have been done like that. And you can say, well, look, I had only one analysis planned right from the start, and this is what we concluded from it. So I actually think that, as well as increasing, replicability of particular findings, I think these kind of open practice techniques can take the heat out of some debates as well, because they mean that scientists are being more transparent and are trying at least, to do the whole Odysseus thing of like lashing themselves to the mast and not allowing themselves to just follow their own biases into into the data.
Yeah, that makes sense. The next question of this type is about, I think there's something British in here that I don't understand. The questioner says, what are your thoughts on behavioral economics based on Cass Sunstein, et cetera, and the government's nudge unit? So that's the part that I don't understand.
Well, the nudge unit is, it no longer exists within the government. It was started off in the government a few years ago, I think by David Cameron. And it's the idea that you could use these kind of minor changes to the way things were phrased or the way laws work to influence people's behavior. The nudge unit, which is now called the Behavioral Insights Team, has now become a separate company and is now not part of the UK government anymore. But it does still advise the UK government. And I believe that the leader of the nudge unit, David Halpern, is on SAGE, the committee that is advising on coronavirus and so on. So I think the behavior economic stuff is subject clearly to the same problems as psychology research and replication issues and so on. I do worry a little bit when I look through the portfolios from Behavioral Insights team and people like that and just see loads and loads and loads of positive results. Like you don't really see many null results there, and that does make me kind of go, slightly maybe there's not 100% not 100% taken with that.
Can you explain that just really quickly? Why would you want to see null results to know that they're trustworthy?
Even if a finding is real, even if a finding is definitely the case, definitely true, just by chance you would expect to see some studies that produce that don't show it, that find that actually that are unable to distinguish that result from chance. Across a whole set of different findings, you would expect there to be some blind alleys. You would expect there to be some experiments that just didn't work out so well. You'd expect there to be some studies that didn't work or didn't show what the scientist was predicting. And if all the studies in the field, and by the way, in psychology, it's something like over 94% of the studies show positive results for what the scientist originally was predicting, then it does imply that there are lots of negative results, but they're hidden away in the file drawer where nobody gets to see them. Because of course, people are making the decision for what to publish based on, not based on the quality of the experiment, and the quality of the methods and the design of the experiment, but they're making the decision based on what the results say, whether they're positive or negative, and mainly whether they're positive. And so I do see it possible. I mean, I haven't analyzed this. Don't quote me on this. I just get a slight impression that maybe, and also the findings sometimes and sometimes don't get published in scientific journals. Sometimes they're in kind of like these kind of brochures of here's our cool new finding and so on. And I would rather they were published in scientific journals and given proper peer review and data were made available and so on. I do think a lot of the nudge stuff is probably subject to the same kinds of like hype and so on. Like there was the original book Nudge, which has been criticized on the basis of the data are not that good. But then there are individual experiments that the data do look better in, where there are nudges that can improve various policies. There are small changes we can make that make a big behavioral difference, and they're very smart and very clever. And there are so I totally believe it, but I do find it a bit of a mixed bag.
Well, I think we have time for maybe just one more question. So this connects to something I asked before. The questioner asked, how should I, as a layman, incorporate all this into my understanding of science and how I might use it to make decisions in daily life, and just how I use it to understand the world?
Yeah, well, I mean, if you'll allow me to plug the book one more time, there's an appendix in the book where it's like top 10 things you should look for when you're looking at a scientific paper. We've talked about a couple of those already, like the discussion around it, specific aspects of the statistics, even basic things like are the authors from a university that you've ever heard of before, or are they possibly from a business? You often see scientific results in the media, and it's not actually a scientist that's done this. It's like some kind of publicity stunt from some firm that's trying to sell you something. So there are basic things. What journal was it published in? Was it published by a journal that looks like a fake? If you go on the website, it looks like it's from the 90s, or is it in a more reliable place? Of course, the whole book is arguing that journals are not necessarily reliable, right? So these are not
not foolproof.
Yeah. Are the scientists being open? Do they publish their data? Is there a pre-registration where they planned out their analysis beforehand, and so they weren't able to use all these flexible techniques that allow them to kind of get the results they want? There are all these things you can look out for. But I think a fundamental thing is just don't base any decisions on one paper or even a small amount of papers. Like, we have to be much more provisional with our knowledge. Knowledge is always provisional. Something's going to come along and check on it later. This is the lesson of the replication crisis, is that you can't necessarily rely on findings, even if they're published in very prestigious and really nice journals, to replicate when someone else comes along. So relying on just individual studies is a really bad idea. And you see all these kind of media firestorms that are on the basis of one study. It's probably just that you should just hedge for a little while. Just say, look, I don't really know the answer to this. We'll wait until more data come in. And I think the media incentives are clearly based on, we must press release this one study. And I don't think scientists are blameless at all in that in that whole problem.
Well, thank you so much. I don't know if I should be handing it back over to Moenza now.
It's a great pleasure. Thank you so much.
Yeah, I had a lot of fun. Thank you to the audience for attending and for all your great questions.
Yeah, thanks, everyone.
Yes, thank you both very much. I really enjoyed that. And hopefully everybody in the audience enjoyed it. I'm sure they did. It will be back again in 2 weeks on the Tuesday, the 3rd of November, again, 7 p.m. UK time, for a session about automation and utopia. And that'll be John Danaher. I don't know how to say that name. in conversation with Brian Earp. Thank you very much and good night.
Great. Thanks, everyone.
Thank you, both of you.
Good night. Cheers.